Find the grade tangent to the curve at point E as a percent. In this problem, vertical curve AC extends from point A to point C. Line segment AB is tangent to the curve at point A and has a grade of 2.00%. Point D and point E are both located on the curve. The stationing for points A, D, and E are provided, and the grade tangent to the curve at point D is 0.00%. To find the grade tangent to the curve at point E, we'll use the generic equation to find the rate change of slope, r, and redefine the variables for our specific problem. For example, variable g1 refers to the approach grade, which is the same as the grade of line segment AB. For this problem, we'll simply refer to this grade as GA, since it is the grade of the line tangent to the curve at point A. The variable r is the rate change of slope in units of percent per station. Variable g2 refers to the grade or slope of the curve down station from the point used for grade g1. And L refers to the length between the 2 points used to take grades g1 and g2. For example, if g1 is the grade at point A and g2 is the grade at point E, then the length L will be the length from point A to point E. Since we want to find the grade at point E, we'll isolate variable GE. GE equals the grade at point A plus the rate change of slope times the length of the curve from point A to point E. The problem statement provides the grade of the curve at point A, but we don't yet know the values of R or L sub AE. L sub AE can be determined by subtracting the stationing of point A from the stationing of point E. After plugging in the variables, length AE equals 4 plus 40, or 4.4 stations. To solve for R, the rate change of slope, we'll start with the same generic equation for R we saw earlier. As before, we'll substitute GA for G1. However, now we'll use the grade at point D for variable G2. For this scenario, L refers to the length from point A to point D and equals the stationing at point D minus the stationing at point A. After plugging in those stations, L sub AD equals 3.20 stations. Plugging in the variables for GD, GA, and L sub AD, the rate change of slope of the curve equals negative 0.625% per station. Plugging this value into our equation for the grade of the curve at point E, as well as substituting in the grade at point A and the length from point A to point E, the grade at point E equals negative 0.75%. When reviewing the possible solutions, the answer is D.